we cut the E61 in a kind of this quarter area, just so you could see the insides of it and how it actually worked. Thought it'd be interesting for some of the barista community out there to see exactly how these things operate, because there's a lot of confusion over what this thing actually does.
Okay.
So let's go through a little bit about it. This is, let me make sure it's in the off position. So this, what you don't see in the back here is the two tubes that come in here that create the thermosiphon.
Okay.
And let's go through that first real quick. So inside an E61, in this particular one, we have a heat exchanger model, which means there's two boilers. It's a dual boiler, but one boiler is inside the other one, and it exchanges heat with the steam boiler in here to the brew boiler. That's why we call it a heat exchanger. Now, when that when the water inside the heat exchanger heats up, the water rises and it comes up through this tube, goes through this tube, out into this area, and then it loses its heat to the E61 group head. The water cools down and it goes back through this area, comes back through this tube, and enters through the bottom of the heat exchanger boiler. So essentially, when this thing's heating and cooling, it just continuously cycles water through this thing. It's very, very slow, but it still cycles water through. And that's what keeps the group head hot, which is pretty important.
Okay.
Okay, so when it's in the static position, here is what we call the, I'm going to call it the brew valve. When this is closed, no water goes to the coffee. And this is the exhaust valves down here. There's two of them. The main one is down here that releases pressure from the puck, or the coffee puck, when the brewing process is done. So water will come in through here, up through this small area on the top. Some people call this the mushroom. And there's a small jiggler or flow restrictor jet that has a little 0.6 millimeter orifice, and it allows water to come down through this area right to here. And so we have pressurized water up until here.
Okay.
Now, when we put the E61 to the first position, I'll just hold this in place, we'll notice two things. One, that the exhaust valve will close, along with this exhaust valve. There's two of them. And the brew valve will open. And what that does is allow water to come through this area, fill up this chamber, then go up this path, down here, and out into the coffee, which the portafilter would sit right here. And this is the little, call it a diffuser. The water would hit here and go out these little holes, which would spread it out a little bit before it hits the screen.
Okay.
Now, so that is in the first position, or what we call either low pressure or pre-infusion, where there would be no pump turn on, but it would still have some pressure remaining in the brew boiler, which would force water through here and out into the coffee. It would only be a little bit if it's not hooked up to the water mains.
Okay.
If it is hooked up to the water mains, then you have line pressure, whatever your water mains is, down through here and into the coffee.
So is there any kind of like rough estimate on what that pressure might be in this closed circuit if it wasn't connected?
So this has an overpressure valve, which is probably around 9 bar for this particular machine. Some of the other machines can be up to 12 bar. So you can have anywhere from 0 to 9 bar in this machine, in this particular boiler. So depending where the heat cycle is, it can have up to 9 bar pressure.
Okay.
So if you happen to hit it at 9 bar pressure, and you'd probably, do you see brew pressure on this one?
That's steam pressure.
Okay.
Only, yeah.
So you could have up to 9 bar pressure, which would push some water through. Not a whole lot, because it's there's nothing pushing the water through. It's just some extra pressure forcing water through the coffee.
Would my elevation affect that?
Not in the brew boiler. In the steam boiler, yes, where there's a combination of water vapor and water. But in the brew boiler, it's locked, or it's completely full of water. So your elevation won't necessarily change that.
Okay.
Water boils at a different temperature at elevation.
Yeah.
And it could affect pressure slightly in here, but nothing significant.
Okay.
So let's see. So now we can push this up to the second position, which would turn on the pump. And it really just opens this slightly more, which has no real effect, but it just turns on the pump, and then now it forces water through this area into the coffee.
Okay.
Then when you're done brewing, you come down to this second position. I'm going to hold this in place so it works properly. Comes down, opens this valve a little bit first to relieve a little bit of pressure, and then closes the brew valve and opens the exhaust valve, and you get a little squirt of water out the end, because that is releasing the pressure that's held within the portafilter here, so that you can remove the portafilter immediately.
So it's a mechanical method for that brew pressure release.
Correct. So essentially this is a mechanical three-way valve. We have one port that's the exit to the coffee, one port that's the intake of the water, and one port that's the exhaust. So intake, exhaust, and the coffee.
Cool. All right, Brendan, do you have any questions about this?
Is there any difference between the two exhaust valves? Like, could they just have one in there? Why is the design two kind of adjacent to one another?
I don't know why they started this way, but it has something to do with putting some extra hot water into this area before the exhaust, because the more you can dilute that coffee that's coming out of here, the residual coffee coming out, the less chance you're going to have to clog this area.
Mm-hmm. I see. And then I noticed when the technicians here at Seattle Coffee Gear repair an E61, like just the standard tune-up, they repair both of these. I mean, they replace them entirely. And then one other valve somewhere.
This one right here.
Yeah. Now I see that there are these black gaskets in here. Can you just replace those and then use the same old ones with? Or are those replaceable or not?
I don't know if they actually sell those is the problem. There's a little black rubber gasket on each one that fits up against these little machined-in seals area. And although you could probably get these out, I don't know getting new seals back in would be very easy.
I see.
It looks to me like they've rolled over the edge right here, so it'd make it a little bit difficult to replace those.
And why? What is that? Just from use? It's just wear and tear kind of stuff?
Yeah, exactly. So essentially you need some elastomeric product to seal against this copper sealing surface.
Okay.
And typically there's many compounds you can use. There's no compound really yet discovered that can last forever in a coffee machine. Since it's up at temperature, this rubber component, depending on use and how long it's in contact here, will deteriorate over time, and typically what you have is the rubber hardening over time. And the harder it is, the more pressure it requires to seal on the surface. And as soon as it gets too hard, the spring can't seal the surface anymore, and that causes some leaks.
So the kind of symptom for that this needed to be rebuilt would be you'd have excessive leaking.
Exactly. You'd have just some leaks coming out of this exhaust port right here.
Got it.
If the exhaust valves are leaking, it would come out of here.
Okay.
And I guess if the intake valve was leaking, it would also come all the way down through here.
Could scale buildup also do that as well, right? If they weren't cleaning
Correct.
out, then it would.
So typically, the scale buildup is pretty hard to do right on the actual sealing surface. It kind of tends to go around that. I wish we had a damaged one. This one's pretty new. Scale buildup will happen around it and eventually go into the ring surface where it seals. And usually the scale buildup is not the problem, but it's a piece of scale that chips off and gets stuck on that surface so it doesn't seal all the way around properly.
Okay. So that would be another leaking out the exhaust down here.
Correct.
And so this is a Rocket E61 that we've used as the example, but this is this technology is just the E61 technologies, regardless of manufacturer?
For the most part, there's little differences in some of them, but if somebody says they're using the E61 group head, it's typically this setup right here.
Okay. All right. Any other questions, B?
Maybe it would be helpful for people to see the path of back flushing.
And
where it's going and what it's doing.
Right.
What it's addressing.
Yeah.
So when you back flush, there's the path for the water comes in through here, comes down through this seal, goes up here and down through here to the coffee, or the portafilter that has the coffee in it. So when you turn the machine off, the extra coffee goes back up through here, boom, out the exhaust. So when you back flush, you pressurize with water, and then you release, and it back flushes, and the water goes out through here. You pressurize again, and water goes in through here, and then you turn the machine off, and then the water comes back through here and goes all the way out. So on, water goes this way. Off, water goes this way.
Okay. And so backflushing, that's the primary system that it's designed to address.
Correct. So, and the reason for backflushing in this case is that when you turn the machine on, water goes out here, but when you turn the machine off, you have dirty coffee water coming back through here, filling up this area and going through here. This area is not so important, but when you turn the machine on, fresh water comes in this area and then goes back in through here. So this particular area right in here, this chamber and then these two pathways are important to keep clean, because if there's dirty water in there, that when you turn the machine on, dirty water is going to go into your coffee before the clean water does. So you want to keep those particular areas clean.
Cool. All right. Anything else, Brendan?
I don't think so. That answered all my questions.
Yeah,
Great.
cool. Thank you so much, Bill.
You're welcome.